The equation 24x squared plus 25x minus 47 divided by ax minus 2 is equal to negative 8x minus 3 minus 53 over ax minus 2. So it's saying that this is true for all values where x is not equal to 2 over a, where a is a constant, right? So we know that a is going to be a number like 2, 3, 4, whatever. And it's asking for what the value of a is, right? So first we have to conceptualize what the problem is actually asking. And right here you see, and it's basically saying what value of a makes this side equal to this side. So first let's write this out. The first thing that you want to do is you want to put, whenever you have this, right, you always want to put the form on the left equal to the form on the right. They have to have the same structure, right? The SAT puts a lot of form on structure and kind of understanding how to manipulate expressions in order to make them look the same, right, on both sides. So how would we do this? Well, first of all, you see this, they don't have the same denominators, right? And the first step to making them equal in structure is by giving them the same denominators. And how can we do that? Well, we can do that by multiplying both sides of the equation by ax minus 2. And when you multiply ax minus 2, right, you distribute it to both, right? And right here, it's going to cross out. But it's still going to go and distribute to negative 8x minus 3. And this also crosses out over here. Alright, so once you do that, you're left with this, right? You're left with 24x squared plus 25x minus 47 with this right here, right? And what you have to remember is that when you kind of multiply these two, you have ax minus 2 multiplied by negative 8x minus 3, right? And all of that's being subtracted by 53. You have to remember to use the FOIL method, because if you don't, then you're going to multiply these two in such a wrong way, right? So you have to remember first, outer, inner, last, right? So this kind of gives you negative 8ax squared minus 3ax plus 16x plus 6, right? Following this. And all of that is subtracted by 53. So now you're left with this. And as you can see, you have pretty much the same form. On the left side, you have an x squared. On the right side, you have an x squared. On the left side, you have an x. And on the right side, you both have an x, right? And then you also have negative 53 combined with 6 is going to equal negative 47, right? So now we can kind of replace this right here with negative 47. And the structures look pretty similar, right? So we kind of accomplished the first step of making them have equal structure. And now comes the next step, right? You could either plug in randomly, if you don't know where to go, from the answer choices, right? Or you could kind of single out one of these things. Because what you have to do is for these problems, you have to be able to single out certain variables based on first what variable they have, right? And what exponent they have. So from here, we could actually single out 24x squared and negative 8ax squared, right? Because remember, the reason why we could do this is that this is going to be replacement. So we have negative 8ax squared, right? And we have to find what value of a satisfies the equation, right? And because of the fact that this is not going to combine with any other variable, right, we can just set it straight up equal to 24x squared. And whatever value of a makes this true is also going to make the rest of the equation true, right? So right here, we could just get rid of the x squared, right? Through simplification, we divide by x squared because both sides have it. And now we have 24 is equal to negative 8a, right? And then from here, it's a simple solving for a. You divide by negative 8, and 24 divided by negative 8, a is equal to negative 3. And that is your answer. So you always have to kind of first understand what the problem is asking you. And remember that in these types of problems, it's all about structure and trying to make the left side look the same as the right so that you're able to solve a simpler equation.